This is a solution to problem 37 from homework 3.2 day 1. We're asked to find all real zeros of the polynomial function and determine the multiplicity of each zero. So to find zeros, we're going to set g of t equal to 0, and that's going to be t to the fifth minus 6t cubed plus 9t. This is how we find zeros, whether real or not. This problem asked exclusively for real zeros, so we can ignore imaginary zeros. We're going to begin by taking out the greatest common factor, which in this case is going to be t. So I can factor out a t, leaving me with t to the fourth minus 6t squared plus 9. You could do a u substitution here, or you could recognize that this is a perfect square trinomial. So this is a perfect square trinomial, which means it factors as the square of a binomial. In this case, it factors as t squared minus 3 squared. And then by the zero product property, I can set each one of these factors equal to 0 because their product is 0. So I have t equals 0 or t squared minus 3 equal to 0. T equals 0 is already solved. Let's solve the quadratic. So t squared equals 3, adding 3 to both sides. Extract square roots, take the square root of both sides. So I'll have t equals plus or minus 3. So my zeros are 0, negative rad 3, and rad 3. And in terms of the multiplicities, I want to know how many times is that each of these zeros occur. So for the factor of t, that occurs one time. T occurs once, so its multiplicity is 1. So it is odd. And for the factors that come from this t squared minus 3 factor, that whole factor is squared, which means negative rad 3 and rad 3 are zeros twice, so their multiplicity is 2, which is even.